Okay, so I find when I talk to people that people, we talk about energy and power and things like this, and people really don't know what the hell we're talking about, okay? And so I really try to put some slides in. There's very basic concepts about power and energy to help people relate to what power and energy are. So everyone has heard about calories, okay? So you buy some food item and it says this food item has so many calories in it, okay? And so what's a calorie? A calorie, a dietetic calorie, a food calorie, is actually 1,000 energy calories. So energy calorie is the energy. A food calorie is the energy it takes to raise a kilogram of water 1 degree Celsius. Okay, so that's definition, and it's the same kind of critter as a British thermal unit. Okay, a BTU. BTU is the amount of energy it takes to raise a pound of water 1 degree Fahrenheit. Okay, so these are energy. Okay. Now, another way that I tell people about a BTU, especially kids, is I see if you burn a kitchen match all the way down, the whole kitchen match, that's 1 BTU. Okay, so then I go on and talk about how many kitchen matches we use every day in our lives, and how many kitchen matches the United States uses in energy in a year, and it turns out to be a lot of matches. So you do this little conversion. A calorie happens to be almost 4 BTUs. And I found out that 2,000 calories isn't considered to be an adequate diet. I mean, it's like a lost diet. Anyway, 2,000 calories a day to live, so 8,000 BTUs a day. Another measure of energy is a kilowatt hour. This is what we pay for electric energy. A kilowatt hour is 3,413 BTU. So we, to keep our bodies going, we need 2.325 kilowatt hours a day of energy just to live. Isn't that neat? You guys are like, this guy's a nerd. Geek warning. Okay, here's power, okay? Power is not the same thing as energy. People mix these things up all the time, okay? But power is the rate of using energy, okay? So energy per time. And when you talk in terms of power or capacity or demand, okay, another name for power is demand, okay? Because your machine, whatever it is, your pump, demands that much power to work, okay, to do what it's meant to do. And the power is really slippery. It's because it's instantaneous. There's no time, okay? So it might change all the time, a little bit different all the time. So we almost always talk in terms of averages. The only time we don't talk in terms of average power is when we're actually sizing electrical components, okay? Like, so how big is a breaker supposed to be? How big is a wire supposed to be? How big is a transformer supposed to be? So when we're sizing those components, if the power flowing through those components goes over some set amount, the component fails, okay? Or the component is a protective piece of equipment and it disconnects the power. So if we need 2.325 kilowatt hours a day to live, we use an average of about 1/10 of a kilowatt over time, okay? So it takes us about 1/10 of a kilowatt to live. Now, the utilities bill demand in the biggest 15-minute average over a billing cycle. Okay, so between the time they read the meter, okay, they read a demand meter, then they reset it, set it to 0. Then the meter sits there and watches each 15-minute interval, and it reports the biggest demand, the biggest power use going through that meter until the next time the meter's read. Okay, this is very important because it's just 15 minutes sets that peak. Okay, so if you have some machine that demands 100 kilowatts and you only run it 15 minutes in the month, the demand charge is the same as if you used that machine all the time, okay, for the demand charge. So you can mull that over because we'll talk about it some more later. They're riveted. So what we pay for in fuel, I've got energy per gallon, and so remember the BTU is like a calorie kind of, and like a kilowatt hour. So I just converted these numbers. You can see what they are. A gallon of diesel fuel has about 38 kilowatt hours. A gallon of gasoline, 34 kilowatt hours. A gallon of propane, 25 kilowatt hours. And there's costs per gallon. And I kind of did a wild ass guess on these, but they're probably fairly close. $3.99 a gallon for diesel, $3.33 per gallon of gasoline, $2.79 of propane. Now, propane is all over the place. If you happen to be in certain places in North Dakota, you can get a gallon of propane for $1, $1.25. Okay, but if you're in San Diego, you might pay over $4 for a gallon of propane. It's very dependent on how much it costs to ship it. So, yeah, they don't put it in a pipeline. Okay. Very critical part of this information is this is at 100% efficiency. Okay, so this is just converting those raw numbers in fuel. Then for electric energy, Northwestern Energy, we pay if you're non-demand, if you're not a demand customer, your irrigation costs about 9 cents a kilowatt hour. If you do have demand, it's about 6 cents a kilowatt hour because part of that, your energy bill is paid for in demand. Okay, Flathead Electric Cooperative, which is, I sort of use it as a surrogate for all the co-ops. They're all a little bit different, but they're all co-ops, so they have similar supply situation, so their rates are kind of similar, but they have on-peak and off-peak rates, and so you can see what they are: 6 cents, 5 cents, off-peak 3 cents, 3.5 cents. Not much difference in on-peak and off-peak.
Irrigation charges typically tiered. I know Flathead did that for all the regular customers. Your first X kilowatt hours are at a lower rate. Your next ones are at a higher rate. So the more you use, your per unit cost goes up. Which Bonneville mandated they do it.
Yeah, and the thing about these rates is anytime I'm working with any customer, I try to find out from the utility exactly what rate they're on. So if they're on Northwestern Energy, the very simple, small, rural electric utility has over 300 different rates. Right. This is a very simple utility, has over 300 different rates. So when you talk to somebody in California, they're on Southern California Edison or Pacific Gas and Electric, and a lot of times I try to figure out how they're paying for their electricity. A lot of times I have to call the utility and say, help me understand this rate, because they get wild. You have on-peak, off-peak. This, what you're mentioning, is called an inclining block rate. It's rare. Much more commonly is declining block rates, where they pay less for a kilowatt hour. If, like, they'll maybe pay.
Because they had Bonneville made all their customers do it, all the wholesale.
Yeah,
it's an energy efficiency thing, so that when you save one, because they actually lowered the lowest rate, so your average bill didn't go up when they went to this. But now if you save 1 kilowatt hour, you save 9.8 cents.
The highest rate.
6.2, which is still your average.
Mm-hmm.
But it makes it much more likely that saving, 5% of your electric use will pay off.
Yeah, there's, in California, they love inclining block rates. And I worked with a customer in California. He said, I want to put in solar electricity, but I want it to be cost effective. It has to pay for itself. And so it happens that in Pacific Gas and Electric territory, the highest rate is 35 cents a kilowatt hour. Okay, so at 35 cents a kilowatt hour, solar electric is cost effective. So what we did was we sized the solar electric system just to produce that energy that would bring that top rate down for that customer to make it cost effective. So it, yeah, but in Montana, normally it's the other way. There you pay 10 cents for the first 400 kilowatt hours, and then you pay 8 cents for the next 1,500 kilowatt hours. Then you pay 6 cents for the, anything over that. That's more common. So, but the rates are very complicated, and as I say, to really know what the farmer is paying, if the farmer says, God, I just don't get these rates, I just don't understand them, sometimes you have to call the utility, or you can call me, I'll call the utility, and find out exactly how they're paying for their energy. Montana, Dakota utilities, irrigation non-demand, 9 cents, irrigation demand, 6 cents, very similar to Northwestern Energy. So then we pay for demand, okay, if we're a demand meter. So here's, I think that this is really interesting that Northwestern Energy, $9.26 a kilowatt for demand, Flathead, half of that, I mean, what's fair about that? And then Montana, Dakota utilities, we've got some, on peak, $8.30, off peak, $3. So you see, if you have an irrigation system and you can run this irrigation system off peak, which is really most of the time is off peak, but you control this so it only runs off peak, you're going to save that much money. Yeah, it's a lot.
Run on the weekends.
Yeah, just run it, well, or at night.
Yeah.
Okay, so this is 12 p.m. to 8, this is noon to 8 o'clock is on peak, okay? So that's when everyone is, wants their air conditioners running and everything. And so if you can avoid running your irrigation system during that time, you can save a significant amount of money. Doesn't improve the efficiency of the irrigation system, it just saves you money, okay?
So, a quick question about that. We're talking about on peak versus off peak. I guess the question is plant uptake for water. I mean, I don't know that much about irrigation. I've mostly done dryland, so water is a bonus. What is the optimum time for a plant to uptake water when you're doing irrigation?
They use it more efficiently when it's cooler.
So you want to do it early in the morning or late evening?
Yeah, I mean, especially, I answer this question for a lot of gardeners, if you want to do your lawn or your garden in early morning or in the evening. So it has that peak sunlight to dry it out, to minimize issues, disease issues, and stuff like that.
I just finished the level 1 Master Gardeners class. Badass. Okay, and what they said was it needs to be light. Okay, the plants take water in when it's light, and so people that water at night, which is what I always did, I had the irrigation, my sprinkler system come on at night. They said, don't do that. The plants don't use the water at night. Okay, so they said in the early morning. That's so that's what they said. And this was extension.
We don't buy it.
Toby Day.
We'll have to let Toby know that we don't like that answer.
Okay, that's Toby Day said that, so that's
Well,
my source.
When it's dark and you have irrigation though, and it's not using it, you can create some disease issues in your plants.
Right, and they said that also. But the thing is these guys, these irrigation people, they turn those things on at the beginning of May and shut them off at the end of September. And they run 24 hours, you know, and I don't know what to say. This is a little thing about the rate, okay, where they all come from. There's lots of different parts and pieces to it, and the conceptually, the idea of how the utility makes this money is expenses like the linemen's wages and the trucks and the people working in the office and all these, you know, this expense stuff, that is paid for by the energy charge, okay? The transformers, the wires, the poles, the taxes on the right-of-way and all this stuff, this is paid for by demand. Okay, so that's why you get some utilities with a much higher demand charge than others, is because this is how they've chosen, you know, to allocate their, how they get their recovery. You know, they recover their costs and their rates. This shows you the breakdown of where these two are demand right here per kW, and all the other ones are kWh, their energy. And so you can add up the kW, you get the $9. You add up the energy, you get the 6 cents, okay, kilowatt hour. So and then you get you always get a customer service charge. You know, they bill you once per season for your irrigation connection. How am I doing on time? Anybody have an idea?
320.
3:20? Oh, bam.
Good.
Want to take a break or want to keep going?
Just to let you know, Charles said that he's decided to grace us with his presence tomorrow.
Okay.